Boom. Okay, we are recording. All right. So today we are starting our Node block. Node is awesome. Obviously we've been coding with it, but now we're actually going to start utilizing what it was meant to be, and that's essentially on your local machine being able to compile and run JavaScript, whereas normally you could only run JavaScript in the V8 engine for your browser. Node extracts the V8 engine out of the browser and embeds it in its own application, and it makes it so that you can run it locally on your own machine. So that's essentially a high-level overview of what Node is. So this is what we're going to be covering. An overview, the Node modules and what they are, external modules, and debugging Node. So we'll start with the overview. It's just a JavaScript interpreter. Like I said, it's the Google V8 engine extracted out of the browser and embedded into a desktop application. It's a cross-platform runtime environment and a library for running applications written in JavaScript outside of the browser. So like if you're hosting a local server, for example. And it uses a non-blocking I/O and asynchronous events to create a highly performant environment built on Google's V8 engine. I'm running on nothing but coffee right now, so pardon me if I need to keep drinking while I'm going through this. But we've all heard REPL before: read, evaluate, print, and loop. If you wanted to get this console log to print out to your console, then essentially what you would do is call node and run the actual file like this. I don't know why they give this example. Obviously, if you just type in node, it's going to not give you anything. It's a command, it needs arguments, it needs options. You can't just call node and just have magic happen. So obviously here we're actually calling the argument hello.js, and since we're console logging, it actually prints it out to the terminal on your node, or pardon me, like whatever your text editor is, so like Sublime or VS Code. That's where you'll actually see the console output. You're not going to see it in your browser, so keep that in mind. If you're looking for console logs and you're like, why aren't these showing up, make sure you have like a terminal up. Just make sure that you are actually getting the console logs where you're expecting them to go. Okay, any questions about that before we move on? Doing good so far? Awesome. So the common JS pattern is a contract for writing modular JavaScript. Each module is created within its own file and within an isolated scope, so essentially it's just a self-contained file with methods that you can import or export if you're writing it yourself. And the author of the module can specify exactly what functionality needs to be exposed. So if you want to like have, you know, private variables, something that the user can't actually manipulate or mutate themselves, using modules is a very easy way to do that, because you can explicitly declare what you want the user to be able to use and how it acts as the user is using the functionality of that module. And so these are core modules. There's actually three types of modules with Node. There's core, local, and remote/npm. So these are essentially two core Node modules, and require is a method used to import another module's functionality into the focal module. And export is an object used to expose parts of the focal module's functionality to other modules. So this is a built-in part of Node, and you cannot get rid of it. So this is always going to be there as long as you have Node. You don't need to npm install it. It's always going to be there. So what this might look like if you were doing it on your own: you have some variables with strings. You have a function that console logs one of the strings, and then you have another function that console logs another string plus another string. And so now when we're exporting it, you can see we're just calling exports dot whatever the variable name is and then equating it to the variable again. And so when we're importing it, we would say in our app.js file, this variable equals require this file. And so essentially what that does is makes telephone this object with methods attached to it that you would call by using dot notation. So you can see here, by calling console log on telephone dot my number, we will be able to actually access the functionality and the logic in this left file, even though we don't declare or explicitly have any sort of function declaration in our app.js file. And so that's essentially, now it's exposed, we can call it in app.js, and it disappears. But yeah, what you'll actually see is module.exports most of the time. This is typically what the syntax is. So module.exports, dot whatever the method or function is, variable, whatever, and then equate it to what you want to call it on the method. So stepping back for a second, when we say that we're requiring dot phone, telephone dot my number always has to be my number because we're exporting it explicitly as my number down here. So don't forget that, because if you're having a hard time with your functions, you're like, I don't know what's going on, the variable names do have to be the same as the way they're exported. So just keep that in mind. Authoring a module, yeah. Return module.export. So this is just an extrapolated way essentially of how you could return just the object overall instead of having to do module.exports.this, module.exports.that. You could just have an object called module.exports and just export everything within that one singular object. And this is just a side-by-side example of two different ways that you could do this. You guys are probably not going to be writing that many module exports on your own, but this is just like if you were to do this on your own, or like if you just wanted to see what it looks like, this is what it looks like. And so on the left we have module.exports equals a function, and then on the right we're requiring it, and then we can see that we're saying 13 called on 2 is 26, and then we go to the next slide. But yeah, any questions on this? Does that make sense to everybody? Good? Awesome. Okay, so external modules and NPM. So loading external libraries in the browser is typically called a CDN. This wouldn't technically be a CDN because it's just a locally hosted file. But what a CDN is essentially it's a proxy server call to a data center where you are anticipating there to be a certain type of data. So, for instance, let's pull one up here. Like this is actually a proxy server that will go to a specified data center. And this is just a dummy CDN. This isn't a real CDN, but it's essentially going to go to a specific data center and pull out any data or functionality that you want it to, and then it'll bring it back to your actual HTML file and allow you to use the functionality implemented by the CDN inside of your HTML file. And so in Node, what we got going on is with this imported script, we would actually have a require instead. So we're not using a CDN with Node. We're going to be using require because we're loading external libraries using Node's package manager, which is NPM. So we're not going to be using CDNs in Node. It's a different type of importing data, and it's specific to Node. So this require thing again is core to Node, and this is if we were going to use this, we would need to install underscore with npm, unless we actually wrote it ourselves. So like in this instance, you could have require underscore .js, and if you wrote that actual underscore .js, then you would have full control over it, like we just showed on the screen, where you would be able to, you know, specifically call functions and blah, 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 blah. But most of the time what you'll be doing when you're saying require is pulling in these enormous modules that other people have made, like Axios, and that will allow you to, you know, enact like the functionality of Axios and all that. And so, as an example, boop, pump this up. These are rookie numbers. And my terminal is taken over. Whoop. So we can see here in this Node module that it has all these require things, methods, or like modules. I guess it's technically Monday in my brain. So this I'll show you what it looks like on my server, just like a little project I was working on. Here I'm saying Axios equals require Axios, and so when we go into the index.js of Axios, it says it only has this module.exports, and it's saying I require .lib.axios, and that is the only thing inside of this file. So if we go over to .lib/Axios, we can see now there's a lot more of the implemented functionality, and we can actually go through, this is almost like the source code, if you will, of Axios. So we can go in and we can see all the methods that are available, in addition to all of the other things that they're requiring and importing as well. So obviously this isn't the entirety of the functionality of Axios. If I wanted to see everything that it could do, I would have to go into each and every single one of these files and see what the methods they're using are. But this is essentially just like high-level overview of what we are going to be working with when we're saying that we're requiring a module. We are using modules that people have already written that they're exporting, like this right here, module.exports, and then we're calling methods and functions that other people wrote inside of our own personal projects. All right. And once again, this is kind of like what I was talking about before, but your variables obviously need to have the same name. You can't just declare a variable and then try to call it by not using the same name. I don't know why you would do that, but don't do that. And then here, yeah, underscore, and then we're calling the method on the underscore. Pretty basic. Essentially, it's just an object that we're calling methods on. So npm. I already gave this away, but it's Node Package Manager. So it's the package manager for JavaScript, rescues you from dependency hell, and comes pre-installed with Node. And if you want to read more about it, you can obviously go to the website. I'm sure some of you have already seen it if you were looking at some of the documentation of some of the npm modules that you were using. So essentially, it's just, it saves you from the headache of having to remember yourself of what you're using and what, you know, like if it needs to be updated. It's just an easier way to keep track of exactly what modules you're using and what version they are, and if they need to be explicitly used for the development environment or the production environment. You can actually specify that with npm. So if you want like a specific testing module to be available in the development environment, you can specify that with npm. And the same way with production, if you want something to only be available in production, you can specify that as well. So we talked about core modules like require and export, but there's a couple other ones as well: FS, HTTP, URL path. If you want to, you can just look up a list of exactly what these are. It's available on Node's website, but essentially these are just like, you know, core functionality things that you might expect, like a server IDE to, well, it's not an IDE, pardon me. A server like, how do I say this? It's essentially, it gives you everything that you need to start. So like, this is like the basics of, if you wanted to create a server, you could just require this HTTP module, and you could call http.createServer, and that would allow you to actually host the server on your local machine. So like right here, I say let HTTP equal require HTTP, and then down here, I say let server equal http.createServer with the request and the response expected. If the request method is get and there is a request URL, then I call this function that I declared up above, and that's what handles the HTTP request. But when I actually spin up this this server, down here, I call server, as we declared it up here, .listen. So essentially we're calling another method on HTTP, but it's extracted a little bit because we're calling it on the variable that we declared as the server. We're passing in the port that we're going to be listening on, and then we're just going to console log that we're listening on that actual port. And so what that would look like is we go in and we do node server.js. And so now we can see I've spun up the server and I have my secret key here for making API requests. And if I wanted to go into, well, let me come out of there. If I go to localhost 8080 and I go back, I should see a request. So you can see here, I have spun up a local server using Node very easily by using the core modules. And obviously this request failed because all I did was just request the URL that I didn't anticipate. So the way my application works is it needs to have a number passed in so it can query this website. And since I didn't pass in a number, it's saying, I don't know what you want me to do here. This is, and then it sends back this error because it's like, I don't know what the heck is going on. So this is essentially a core module on Node that you would use to create a locally hosted server. And side note, you could use this to actually serve pages to the World Wide Web. That would require you to port forward, is what it's called, which is kind of unsafe. But theoretically, if you wanted to, you could host a server locally and forward that port and then allow people from outside to make specific HTTP requests to your IP address at that port. So this is how essentially, you know, like game servers work. It's essentially how like everything is serving data, but like if you wanted to do it yourself, it is possible. It's just considered unsafe. Really small. Okay. So yeah, that's an example of what HTTP looks like. FS is file system, so if you wanted to go through your local directory, you know, like pictures you have on your computer, blah, 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 URL, blah, 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 all included with Node. So debugging Node, we've kind of already seen this before. Essentially, as I said before, the terminal is going to be console logging, not your browser when you're using Node. So make sure that when you're in your server.js file, you understand that it's not going to console log to the browser. You need to keep an eye on your terminal as well. You can use Chrome DevTools with debugger breakpoints, obviously. Let's pull that up so we can get a better look. All right, so we could call node inspect on a JavaScript file, and then we get back, you know, the debugger is listening on our locally hosted server at this specific string. If you need help, here's the docs, debugger attached, blah, 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 blah. And then we'll set breakpoints by calling debugger, and that will essentially stop our code at that exact moment and give us a snapshot of what all our variables and functions look like and what the call stack looks like and the event loop and everything. Yeah, obviously we're debugging, so we're just taking the code, stopping it at certain points, and just taking a look under the hood to see what's going on underneath. And that's it. Quick sidebar, we'll probably talk about this more as the week goes on, but essentially what's going on when you're making requests to any server through your browser is your locally hosted machine is going to send a request to the domain name system, and it's going to query a chain of different servers. I wrote them all down. There's actually a bunch. So first, it'll go to the resolving name system, and then it will hit the root name servers, and then finally it will go to the authoritative name server. So the DNS is actually a huge combined network of servers all working together for specific purposes. Essentially, each level is asking if that specific server has a memory of what you're looking for. So like if you query google.com, the first server it hits, resolving name system, if google.com is cached in there, it will immediately return that IP address to your computer. If it doesn't resolve at that first RNS, then it will continue on to the next server. And so, first one is RNS, resolving name system. 2 is the root name servers, which is the same acronym. This is resolving name system. Nice. Authoritative name server. So the DNS isn't a singular thing. It's actually a huge network of connected servers that will go through this chain of operations where if this resolving name system doesn't have what you're looking for cached, it'll ask the RNS, and if this doesn't have a cache, then it'll ask the ANS, which almost always has it, unless it's obviously like not a real website. But this all happens under the hood within seconds. Obviously, if you go to google.com, it doesn't take more than a couple seconds to load the page. But essentially, under the hood, what just happened is we just went through that process of looking through the domain name system to see where this IP address is located. So once we finally find the IP address, then the server will query any commands that we have to their database if we need it. Like obviously if we're going to google.com, we're not querying their database, at least yet. But essentially what happens when you make a request is your CPU sends out the domain name system evaluates what the domain is, it finds the IP of it, and then if we're sending an HTTP request, if it has a body or if we're specifically looking for something using parameters, then it will query its database located on its server, its local server, and then it'll send it back through. It doesn't actually hit the domain name system, so it would, if it was going back, it would just hop on back over to here. And then the reason that we have the domain name system is so that we can have domains like google.com and have that evaluate to an IP address so our computer knows exactly where to go. If we didn't have the domain name system, we would literally have to remember the IP addresses for every single domain, and obviously that doesn't sound like fun. So this is a pretty integral and important part of the way the internet works because it makes it that much more accessible and readily usable to us, like the end users. And so we'll probably talk about this more as we get more into like SQL in this quarter, but high level overview, this is essentially what's going on when you're making a request. Maybe you have a database yourself. If you make a specific request, and you get the data back, maybe then you'd want to put it back in your database, but essentially we have our computer, the domain, to the server, grab any data we might need, and send it all the way back, and then if we need to, we can store it back in our database. But don't worry about that too much right now. It's just kind of like a snapshot of what we're going to be getting into as the quarter goes on. But yeah, that's essentially Node. Are there any questions on Node before we break out for the rest of the day? High level overview, to wrap this up, Node is just an application level JavaScript. It's the abstracted V8 Google engine on your machine, so you don't need a web, you don't need an internet connection. You can just write and evaluate JavaScript on your actual machine. You don't need a browser. That's, if I had to explain Node in one sentence, that would be it. It allows you to write and run JavaScript on your local machine. So we'll talk about it more as the week goes on, as the quarter goes on, but Node is great, and we're going to start using it to create our own databases and our own servers to host and serve data as the quarter goes on. So yeah, that's Node, guys. Thanks for listening to me ramble. The rest of the quarter, let's see. So for today, do you guys have the schedule? For today? Okay. I'll talk. I don't see why we wouldn't be able to send this out. Right now it's currently labeled as tentative, so it's subject to change, but I'll send this out with that caveat. Just know that this isn't completely 100% set in stone. So for today, we're going to just continue working through, learn on how the web works, starting Node basics, and setting expectations. So hopefully I helped you out a little bit with the expectations. We're going to be working with SQL later this quarter. We're going to be working with a JavaScript library called Express and Connects. And Connects is another library that essentially evaluates JavaScript to SQL. So we're going to be working with SQL and running our own servers and being able to run our own backends for our own applications, essentially. So it's really cool. It's really exciting. I like it a lot. Node is really fun. But yeah, that's all I have for you guys. Feel free to Slack me, obviously. Otherwise, I will stop this recording, and you guys can